Alright, boys and girls, welcome to our last video lesson in Chapter 2. This lesson has to deal with rational functions and their graphs. Okay, here we go. When you graph a rational function, you're going to follow the following steps. Okay, and a rational function is defined as two polynomial functions in a fraction. So the top polynomial function we're going to call n of x, n of course standing for numerator, and this bottom polynomial function we're going to call d of x. D of course stands for, you got it, denominator. So a rational function is a fraction of polynomial functions. The steps to graphing a rational function is to factor both the numerator and the denominator. So factor both the top and the bottom. Note any holes, just going to be a hole in the graph, and that's where we have the same value or same factor for x. So we find the value of x for factors that are the same in both top and bottom. 3, we're going to find the y-intercept. We do that by letting x be 0. We're then going to find the roots of the function. We do that by letting the numerator be 0. In other words, we're going to let the y be 0, and we do that by letting the numerator be 0. Any fraction where the numerator is a number over any value for n other than 0, that fraction is going to have a value of 0. Then we find the vertical asymptotes. We let the denominator be 0. We find the horizontal asymptotes, and I'm going to show you in class how to do it the long way, but there is a shortcut which we'll go through in a minute. This is the long way, and the shortcut will be our next slide. There are times when we will not have a horizontal asymptote. Instead, we're going to have a slant asymptote. We're going to have an asymptote a horizontal asymptote that is on a slant. And that's going to happen when the numerator has a power of 1 more than the denominator. Okay? Then we're going to lastly plug in any additional values to get our graph. The shortcut for finding the horizontal asymptotes is really quite simple, and it makes sense. If the degree of the numerator is less than the degree of our denominator, our horizontal asymptote is y equals 0. It's the x-axis. If the degree of the numerator is equal to the degree of the denominator, then our horizontal asymptote is going to be the fraction that is the leading coefficients of our two functions, the numerator and the denominator. Okay, if the degree of the numerator is 1 greater than the degree of the denominator, we have a slant asymptote, and we find the slant asymptote by dividing the denominator into the numerator. And lastly, just keep in mind, if the degree of the numerator is 2 more than the degree of the denominator, then we have a parabolic slant asymptote. Okay? Okay, so as we look at this problem right here, first step is to factor both the numerator and the denominator. Notice that this is already factored. Okay, the top is just going to be 3 in factored form, and the bottom, of course, is going to be x minus 2 times x minus 2. We just factor that. Okay, therefore, notice that there are no holes, and that is because there are no common factors in both top and bottom. Our y-intercept we're going to find by letting our x be 0. Okay, so we find the y-intercept like we do any other time by letting x be 0. So in this case, we're going to have 3 over 0 minus 2, which is negative 2, squared, which of course is 3 over negative 2 squared is 4. So our y-intercept is 3/4. Our x-intercept, we let the numerator be 0. So we let the numerator, which is 3, equals 0. Well, 3 does not equal 0. It never will, so there is no x-intercept. There are no roots. Okay, so continuing on now we're going to find our vertical asymptote. We let our denominator be 0, so we need to let x minus 2 squared equals 0. Well, of course, that's just when x minus 2 is equal to 0, which is when x is equal to 2. So our vertical asymptote is at 2. And our horizontal asymptote, notice that the degree of the top is 0 because it's x to the 0. And our degree at the bottom, if we FOIL that out, we don't need to, but we can see that the degree of that is 2 because we're going to have an x squared term. The degree of the numerator is less than the degree of the denominator, so therefore our horizontal asymptote is y equals 0, or in other words, the x-axis. Okay, so if we want to graph this thing now, we have no holes, we don't need to worry about that. Our y-intercept is 3/4, so that's going to go right here. Whoop, I need to turn my pen on. Our y-intercept is there at 3/4. I have no roots, I have no x-intercepts. My vertical asymptote is at x equals 2. That's a dotted line in case you were wondering. And so now our graph, our horizontal asymptote is at y equals 0. So it's our x-axis. Okay? So our graph is going to hug the horizontal asymptote, pass through my y-intercept, hug the vertical asymptote, and now we need to decide what our graph looks like on the right side of our vertical asymptote. We can do that by plugging in a point such as 4. If I plug in a point like 4, that's when x is 4. So I'm going to plug that in, and notice I'm going to get 3 over 4 minus 2 squared, which equals 3 over 4 minus 2 is 2. 2 squared is 4, so that's 3/4. So I'm going to have a point right here at 3/4, which now means that my right side of my graph is going to hug my asymptotes passing through that point, and it's going to look like that. There's my graph, and we'll talk about this in class 2, but I do want you to have this example. Let's try another one. We have 2x plus 6 over x squared plus 5x minus 6. First thing I'm going to do is I'm going to factor the top. Well, that's 2 times x plus 3. I'm going to factor the bottom, and that is x plus 6, x minus 5. Notice I have no common factors, so therefore I have no holes. My y-intercept is going to be when x is 0. So that's if you look in either the factored form or the unfactored form. If I look in the unfactored form, it's actually easier. If I let x be 0, I have 2 times 0 plus 6, which equals 6, over 0 squared plus 5 times 0 minus 6, which of course equals negative 6. 6 over negative 6 is negative 1. My y-intercept is negative 1. My x-intercept is when the numerator is going to be 0, so I set 2x plus 6 equal to 0. Solve that for x. I'm going to get 2x is equal to negative 6, so x equals negative 3. So my x-intercept is negative 3. I only have one root. Okay, let's find our vertical asymptote. We're going to do that by letting our denominator be 0, so we need to find out x plus 6 times x minus 1 is equal to 0. It's just solving a quadratic equation. For that to happen, either x plus 6 is 0, which means x is neg 6, or x minus 1 is equal to 0, so x is positive 1. So our vertical asymptotes are at negative 6 and at 1. And our horizontal asymptote, notice that the degree of the top is 1, and the degree of the bottom is 2, because I have an x to the first over an x squared. The degree of the top is less than the degree of the bottom, so once again, my horizontal asymptote is 0. Let's move on to our next slide. Okay, I knew there were no holes. I knew my y-intercept was negative 1. I knew my x-intercept was negative 3. I knew my vertical asymptotes were at, I'm trying to remember, at negative 6 and positive 1, and my horizontal asymptote was 0. So, I'm going to graph my points. My y-intercept is negative 1. My x-intercept is negative 3. I have a vertical asymptote at negative 6. and at positive 1. And I have a horizontal asymptote at 0. Okay, notice in this case, I am actually going to have a root. My root is at -3, so I may sometimes pass through the horizontal asymptote. But I know that this graph is going to go from my root and then hug the vertical asymptote, passing through also my y-intercept. And if I let x be a number like -5, you can see now up top, okay, and so if I let x be a number like -5 right here, let's just throw that into our function and see what happens. And all I care really about right now is my sign. So I got to figure out where I'm going, whether I'm going up like this, or whether I'm going back down like this. Okay, so we're going to throw in x equals -5. And when I do that, I'm going to get up top, I'm going to get 2 times -2, which is negative. And on the bottom, I'm going to get -5 plus 6 is positive 1, times -5 minus 6 is negative. So I have negative over positive times negative, which is now negative divided by negative, which is positive. So I knew that my graph goes up like this. And now I got to just figure out what's happening on the right side and what's happening on the left side. To find out what's happening on the left side, I'm going to plug in a point over here somewhere. Let's do x equals -10. And I got to decide whether my graph's going to do something like this or something like this. So if I let x be -10, up top I'm going to have 2 times -10 plus 3, which is -14, or if you want, just more simply, it's negative, over -10 plus 6 is negative, times -10 minus 1 is -11, which is negative. So I have negative divided by negative times negative, which is positive. Negative divided by positive is negative. So my graph is going to be below the asymptote because my values are negative. On the right side, let's plug in a value like something to the right of 1. Let's let x be 2. I'll do that in red. If x is 2, up top I'm going to have 2 times x plus 3. 2 plus 3 is 5, so I'm going to have positive up top. Over 2 plus 6 is 8, positive. And 2 minus 1 is still positive 1, so it's positive. So I have positive divided by positive times positive, which is all positive. So my graph is going to be positive here to the right side, so it's going to hug the asymptotes like that. And there is a rough sketch of my graph. Let's try another one. This is 1 minus 5x over 1 plus 2x. It's already factored. There are no common factors, so once again I have no holes. My y-intercept is going to be found when x is 0. I have in essence 1 minus 5 times 0, which is 0, over 1 plus 2 times 0, which is 0. So I have 1 over 1, which is 1. The x-intercept is going to be found by letting the numerator be 0, so 1 minus 5x is equal to 0. If I solve that for x, I get 5x is equal to 1, so x is equal to 1/5. So that's my x-intercept. To find my vertical asymptote, I'm going to let my denominator be 0. So I'll do this in red, 1 plus 2x is equal to 0. To solve that for x, I'm going to subtract the 1, divide by 2, x equals -1/2. So my vertical asymptote is -1/2. Okay, let's just review how I found my vertical asymptote one more time. I let 1 plus 2x equal 0. So I'm going to subtract the 1. So 2x is equal to -1 divided by 2 divided by 2. There's my -1/2. To find my horizontal asymptote, I'm going to look at my functions. The degree of the function is 1. The degree of the numerator is 1. The degree of the denominator is also 1. Notice that the degrees of the numerator and the denominator are both the same. So therefore, my horizontal asymptote is the value of the leading coefficients, which is negative 5 over 2. So if I want to graph my function now, I have no holes. I have a y-intercept of 1. I have an x-intercept of 1/5 right there. I have a vertical asymptote at negative 1/2, so that's right about there. And I have a horizontal asymptote at negative 5/2, or negative 2.5, so it's right there. So now my graph, I can see it passes through these 2 points, so it's going to hug my vertical asymptote, come down through those 2 points, hug my horizontal asymptote. And now we need to figure out what's happening on the left side of my vertical asymptote. My graph is either going to go up like this, or it's going to be down in this corner down here. Let's see. Basically, I can plug in a point, anything to the left of negative 1. Let's plug in negative 1/2. Let's plug in x equals negative 1. If I do that, do we see that up top I have 1 minus 5 times negative 1, which is negative 5, or 1 plus 5 is 6. On the bottom I have 1 plus 2 times negative 1, which is negative 2. So I have negative 1. That has a value of negative 6, so I'm somewhere down here, which means my graph is going to hug like that. And there's my picture. Okay, last one here, let's go. First of all, I'm going to factor both top and bottom. Now looking at the top, to factor that looks pretty tough. So what I'm going to do is I'm going to throw that function into my calculator and come up with the roots. By doing that, if I know my roots, I also know my factors. I found that my roots were neg3, neg2, and pos4. That means I'm going to have factors of x plus 3, x plus 2, and x minus 4. On the bottom, x squared minus 5x plus 4 can be factored as x minus 1 and x minus 4. Okay, so that was step 1. Step 2 is note any holes. Notice I have a factor of x minus 4 on the top and a factor of x minus 4 on the bottom. Those factors are in essence going to cancel. But as they do, they give me a hole at x equals 4. Okay, my y-intercept, I let x be 0. Of course, we know what happens now. All the x terms become 0, so I'm left with negative 24 over positive 4, which of course is negative 6. That's my y-intercept. My x-intercept, I'm going to let the numerator be 0. So my roots now are going to be whenever my numerator is 0, and we just factored this. I've eliminated the x equals 4, but I also now am going to have roots of negative 3 and negative 2. Okay? Okay, so to find my vertical asymptote, I'm going to set my denominator equal to 0. Remember, we crossed out the x minus 4. Okay, we crossed that out. So I'm going to just set my denominator to 0, so x minus 1 is equal to 0, which means x is equal to 1. I have a vertical asymptote at 1. And now let's find out my horizontal asymptotes. The degree of the top, we see we have an x to the third, so the degree is 3. The degree of the bottom, I have an x squared, so it is 2. Notice that the degree of the top is 1 more than the degree of the bottom, so I don't have a horizontal asymptote, I'm going to have a slant asymptote. Okay, to find my slant asymptote, what I need to do is I need to divide the numerator into, the denominator into the numerator. I have 2 options here. One would be just take these 2 functions right the way they are and divide the bottom into the top. To do that, I would have to do long division. But there is a shortcut that I can take. I can also remember what these were in factored forms. Remember, this was up top. I had x plus 3 times x plus 2 and x minus 4. On the bottom, I had x minus 1, x minus 4. Remember, our x minus 4 is canceled. Okay, so I can just divide the bottom into the top like this. So I have x minus 1 into, if I FOIL out x plus 3 and x plus 2, I get x squared plus 5x plus 6. Okay, we can actually do this now synthetically, much easier. So I'm going to do 1 into 1, 5, 6. Bring the 1 down. I have 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. I have a remainder of 12, and that's really not important. Most importantly, my quotient is going to be 1x plus 6. So that is my slant asymptote, x plus 6. Okay, so to make this graph now, I'm going to note, I'm going to just remember I have a hole at 4, so somewhere around here I have a hole at 4. I have a y-intercept of -6 down here. I have x-intercepts at -2 and at -3. And I have a vertical asymptote at x equals 1. I'm also now going to have a slant asymptote where the line is y equals x plus 6. So that would have an x-intercept of +6 and a slope of 1. So we're going to have a slant asymptote that looks like that. Okay? Because these two roots down here, so I have these two roots down here, okay, and the y-intercept, I know my graph is going to look something like this. I'll do it in blue. It's going to hug, go through, loop around, and come down, and then go through that, and then hug my asymptote like that. Of course, that line is nice and straight. Now I just need to figure out what's going on the right side of my vertical asymptote. On the right side, so on the right side of my vertical asymptote, just remember I'm going to have a hole here at 4. Okay, but I just need to decide, am I above my slant asymptote, or am I below it? Let's plug in a number like x equals 3, and just decide if I'm above it or below it. So if x equals 3, okay, we know now I can throw 3 up into the top. I'm going to get 27 plus 9 minus 14 times 3. 14 times 3 is 42. Minus 24. So it looks like I have 27 plus 9 is 36, minus 42 is -6, minus 24 is -30. And on the bottom I'm going to throw 3 in, so I'm going to get 9 minus 15 plus 4, which is -6 plus 4, which is -2. So it looks like I have a value of positive 15 when x is 30. So that's going to be way up here somewhere. So I know that this graph is going to go through and hug my asymptotes like that when I have a big hole here at x equals 4. All right, that's pretty tough, but we'll talk about it some more tomorrow. Have a great day, folks.